last part is quite small here, so I'm just going to increase the size of this by scanning in a wee bit, so hopefully you'll be able to see it and knew which direction to put it. So this is the back of the page. It says a capacitor of capacitance C is connected to a supply voltage which is gradually increased from 0 to a suitable value or to a maximum value Vmax. At a particular instant, the potential difference across a capacitor is V1. Write down an expression in terms of C and V for the energy stored in the capacitor at that instant. So it's C and V, and so E1 is going to be equal to a half C times V1 squared. On figure 2.1, sketch a graph to show how the energy E stored in the capacitor depends on the supply voltage V. So there's your equation. You can see that E1 is proportional to V1 squared. And therefore, if you were going to plot a graph of E versus V, then that has to be an upward sloping curve, which is going to stop at Vmax there. The next part of the question then, and I'll try and scan in a wee bit further there for you. The capacitance of the capacitor is 20 microfarads. Over a period of time, as a result of changing the supply voltage, the charge in the capacitor is changed from 40 to 170 microcoulombs. Calculate the range of supply voltage that produces this change in charge. So all you're doing is a wee sum there with V is equal to Q over C, V is equal to Q over C. And just put the two values in. So do two different sums. 40 over the capacitance is 20, and they're both micro, so whenever you divide those, you're going to get an answer there of 2 volts. And then the second time, do it again, and this time you're doing 170 over 20. And it comes out as an answer of 8.5 volts. I'll put the wee micros there too. So the answer there, it's going up from 2 volts up to 8.5 volts. Part B of this question. It says a capacitor has a capacitance C and carries a charge Q. Write down an expression in terms of C and Q for the energy E stored in the capacitor. Right, now we've got two expressions that you know. So you want to rearrange one of them to make sure that you have got Q in your equation. So you know E is equal to half CV squared, but V is equal to Q over C. And therefore that's equal to half C times Q over C squared. So it's Q squared over C squared. And you can see there that one of your C's in the bottom goes out, and you end up with a half Q squared over C is your answer. Next question. Figure 2.2 shows 3 capacitors of capacitance 2, 4 and 8 microfarads connected in series to a battery. So you have 2, 4 and 8. Which of the capacitors has the least energy stored in it? Indicate your answer by placing a tick in the appropriate box. Explain your reasoning. Now, if you go for the equation, we're going to write down the equation which has got C in it, one of the equations which has got C in it. And the one above, really, very often that gives you a wee clue. Half Q squared over C. A is equal to half Q squared over C. And therefore that means the one with the biggest capacitance is going to divide into this charge to give you the smallest answer. So which one is the least energy? The answer is going to be the one with the biggest capacitance, which is 8. And the reason is, if you use that equation, A is equal to half Q squared over C. This is a series circuit, and in a series circuit you know that the current flowing through every part of a series circuit is exactly the same. Therefore the charge in every part of the series circuit is exactly the same. Therefore each of those capacitors have the same amount of charge stored across them. And if that's the case and you're dividing by different sizes of capacitance, then if the capacitors have the same amount of charge, dividing by larger capacitance means less energy stored. Now there's no reason why you couldn't explain any kind of answer using an equation to help you. And very often, you know, if there's a first part of a question and you have ended up with some kind of equation, you probably have to use that in the second part as well. So that's the end of the explanation there of worksheet 3 that I gave you on capacitors. Thank you.